In this video, we're going to be discussing the range values of our trigonometric functions. So consider an angle theta increasing in measure from 0 degrees towards 90 degrees. So we're going to start here in standard position. And then our angle theta is kind of rotating in this direction. So we can see when theta hits these different values that we can create triangles with our R value staying the same. So we've got these different triangles, right? I got 3 triangles here. As the measure of the angle increases, the Y value increases. So these triangles are getting taller as we rotate from 0 to 90 degrees. But that value of Y is never going to exceed R. Because when we get up here at 90 degrees, our R value is going to be the same as our Y value. So we can conclude that Y is going to be less than or equal to R. If we divide both sides of this inequality by R, it brings us to the conclusion that Y divided by R has to be less than or equal to 1. Well, I'm going to do the similar thing in quadrant 4, right, with a negative theta rotating down. As our angle rotates from 0 to negative 90 degrees, right, at these different spots of theta, we've created these different triangles. And each triangle has a different height. And we see that our height is getting increasingly negative. But just like in quadrant 1, this Y value is never going to exceed R. And we get that Y is always going to be greater than R. And when we divide both sides by R, we get the inequality that Y has to be greater than or equal to negative 1. Well, putting these two inequalities together, that Y is less than or equal to 1, but greater than or equal to negative 1, we get the sandwich inequality saying that Y over R is in between negative 1 and positive 1. And we recognize Y over R to be the definition of sine. So we can conclude that sine of theta is always in between negative 1 and positive 1. So as these triangles were transforming, right, and the Y value was getting taller, we can see on both diagrams that the X value was shrinking. See, it started out big on this first triangle, and then it got shorter for the next triangle, and then it got shorter for the next triangle. So as the measure of our angle theta increases, the value of X decreases. And if we did a similar thought process as we did before, we would reach the conclusion that X over R has to be in between negative 1 and positive 1. And we recognize X over R to be our definition of cosine, so we can conclude that cosine of theta is always in between negative 1 and positive 1. So those are our ranges for sine and cosine. They're always going to be between negative 1 and positive 1. And that's a fact that we're going to use throughout this course. Well, since cosecant and secant are reciprocals of sine and cosine respectively, the range for cosecant is going to be anything less than or equal to -1 or greater than or equal to +1. And cosecant's the same, secant and cosecant. Since cosecant and secant are reciprocals of sine and cosine respectively, and sine and cosine have the same range, cosecant and secant are also going to have the same range. The range for cosecant and secant is everything except what's between -1 and +1. So cosecant of theta is less than or equal to -1 or greater than or equal to +1. And the range for secant is also less than or equal to -1 or greater than or equal to +1. Tangent is y over x, and sometimes x is less than y, sometimes they're equal, sometimes x is greater than y. Therefore, that ratio, y over x, can be any real number. Cotangent is the reciprocal of tangent, and similarly, having that ratio x over y, and sometimes x is bigger, sometimes it's smaller, sometimes they're the same, cotangent can also be any real number. So let's put this together in a summary. So all that hype to get to this right here. The ranges for sine of theta and cosine of theta are between -1 and 1 inclusive. The ranges for cosecant and secant are anything except between -1 and 1. And the ranges for tangent and cotangent are all real numbers. Well, let's use those range facts to decide whether the following statements are possible for some angle theta. Is it possible for a cosine of some angle to be -1.001? The answer is no, because it can only spit out a number between -1 and +1, and that doesn't fall in the range. We want to determine whether cosecant of theta could be 17.12. Well, the range for cosecant is anything except between -1 and 1, and 17.2 falls outside that range, so yes, this is possible. Lastly, we want to decide, is it possible for tangent of theta to be equal to 2 and secant of theta to be equal to -2? Well, tangent has a range of all real numbers, so it can be anything, so this one's good. And secant has a range of anything except -1 to 1. And -2 falls outside of -1 to 1, so this one's good as well. Yes, tangent can be 2 and secant can be -2.